8.2 example 3, modeling exponential decay. So in this example, we've got a real-world scenario where a company buys a piece of machinery for $2,500. The value of Y of the machine decreases by 10% each year. So the way that they're modeling exponential decay in this situation is what's called depreciation. So it's the same thing as when you buy a car from a car dealership, and as soon as you drive away with it, it starts to lose its value. As it's used, it loses its value. It's called depreciation. And most of the time that can be modeled with what's called exponential decay. In other words, it gets progressively smaller and smaller, but at a slower and slower rate as the years go on, because it's a percentage of the current value. So the three things that we're going to do are A, write an exponential decay model for the value of the machine and use that model to estimate the value after 3 years. Okay. B, graph the model. And then C, use the graph to estimate when the value will be $2,000. So after how many years will it be $2,000? So let's start off with A, and let's first get our information over here. So the initial value of the machinery was $2,500. Okay, it's decreasing at a rate of 10% per year. Okay, and the model for depreciation is similar to the model for compound interest, except instead of adding the interest rate to 1, we're subtracting the interest rate from 1, or in this case, the depreciation rate. So for A, it says let T be the number of years since the machine was bought. The exponential decay model is A, which is the initial value, times the quantity 1 minus R, which is the rate of decay, raised to the T power. So all we're going to do here is substitute in for A and R. A is $2,500 times 1 minus 10%, so we need to convert that into a decimal, so 0.1, raised to the T years. And for right now, we're going to leave that as T. So we simplify that, and we get 2,500 times 1 minus 0.1 is 0.9, and then raised to the T power. So if we plug in 3 for T, that would be 2,500 times 0.9 raised to the third power. And if we just plug that in on the calculator, because we really don't want to have to do 0.9 cubed in our head, we get $1,822.50. Okay. So now B, we want to graph this. So we're going to graph the first 2 points. Okay. So if we plug in 0 for A, so we're using our Y equals 2,500 times 0.9 to the T power. Well, if we plug in 0 for T, so that would be at the time that we bought it, that would be 0, 2,500. Makes sense. That's our initial investment. So 0, 2,500. We can't go back in time, so we don't have to worry about going to the left of the y-axis. And then if we plug in 1, well, 1 for T would be 0.9 to the first power, which is just 0.9, and then 0.9 times $2,500 is $2,250. So $2,250. Okay. So 1, 2,250. So that's going to be, let's see, it's going in increments of 500, so 2,250 is It's going to be halfway in between 2,000 and 2,500. And the other thing, all right, so let's see, the asymptote of the graph is the line. Well, it can continue to depreciate as far as we want, but it can't actually reach 0. So our asymptote is y equals 0. So you can't have a negative value for the car. Now we know that also after 3 years, the value is at $1,822.50, so we can also approximate that as well. So 1,822 would be just a little over halfway between 1,750, which is the halfway mark, and 2,000. So we can see that we've got a sloping curve, okay? And I'll try and do this as best as I can. And it's going to get progressively smaller and smaller, but at a slower and slower rate. Okay, so it is curving. Hard to tell there, but it is curving. So we want to see, when did it actually hit $2,000? Well, if you can see there, it must have hit $2,000, which is right there. Okay, so $2,000 must be right at about 2 years. Okay. And if we plug that in just for verification purposes, if we do 0.9 raised to the second power times the 2,500, we find out that that was actually about $2,025 at that time, so pretty close. Okay, and that's how you model exponential decay in terms of depreciation.